Microprocessor, Module 8, the internal architecture. What is CPU? Central Processing Unit is the brain of the computer, performs basic arithmetic, logic, controlling, and also handles all computations needed to turn input and output operations specified by instructions in the program. Simply CPUs do what we tell them or program them what to do, built by placing billions of microscopic transistors into a single computer chip, and those transistors allow to make calculations that is needed to run programs that is stored in a system's memory. Moore's law. Moore's law refers to Moore's perception that the number of transistors on a microchip doubles every 2 years. This law also states that we can expect the speed and the capability of our computers to increase every couple of years, and the cost will be less. On the right side is the graph that proves the Moore's law. History of CPU. November 15, 1971, CPU was invented. 4 decades ago today, Intel advertised the first single-chip CPU, the Intel 4004, with 2,300 transistors and 740 kHz for the clock speed. The picture on the left side is the computer motherboard 4 years ago with expansion card slots that has different functionality, input-output devices, display drivers, memory, and printer devices. And in today's, those all functionalities fits in a very small chip microprocessor that is on the right side picture. CPU architecture history. 1945, birth of digital computing. Electronic numerical integrator and computer, the first programmable general-purpose electronic digital computer. Robert Noyce, 1959, combined multiple transistor in a single chip. 1968, the birth of Intel Integrated Electronics, founded by Gordon Moore and Robert Noyce. John von Neumann popularized a computer architecture that simplified computer design and programming. Computing abstract layers. Computer system used binary numeral system. We have physics, atoms, silicon metals that is put together to create transistors. The transistors act as switches and that turn on and off, logic gates or the Boolean algebra for performing calculations. Functional units allows more complex multiple functions. Execution units, ALU, designing a whole CPU. The microarchitecture is a combination of processing elements, fetch, decode, execute, and write back, to be discussed later. Instruction set architecture describes memory model, supported data types, registers, instructions, addressing modes, external input and output, and behavior of machine code. It is the dictionary of instruction, critical part of modern CPU design. It is connection of the software to hardware. Addition to this is the common instruction set are known as family, the x86 family, ARM family, 68K family, and etc. Microarchitecture. Fetch. Fetch retrieve the instruction from memory so the CPU knows what the program wants executed. Decode, taking instruction and breaking down into multiple internal operations. Execute can perform math, addition, subtraction, multiplication, and division. Or perform Boolean operation. The branches compares data that make decision instruction. For the write back, we have registers that serve as temporary storage devices of microprocessor and the memory. The combination of the four is the pipeline. Pipeline is like a simple line where the more stages added, the less work done in each individual stage. Branch prediction is a purpose that is improve the flows in an instruction pipeline. The speculative execution is a fundamental component and where a computer system performs some task that is not needed. Scalar execution, ALU, can perform operation at most single instruction per clock cycle. Front end is composed of fetch and the decode. It is to ensure that there is always enough instructions available for the back end to execute and to avoid the idle time spent waiting for instruction bytes from memory or time spent fetch instruction that will thrown away due to bad branch prediction. Microoperations is the strongest connection between the instruction set architecture and the microarchitecture, always looking on how to decode and prepare instruction to be executed efficiently. The back end has execute and the write back has superscalar execution where can perform operations more than one instruction during clock cycle. It takes the decoded microoperations, uses superscalar execution and out of order execution to assign microoperations to execute means.